Assalamualaikum and hello everyone. My name is Amzar Razik Khan bin Azamhan and my metric number is B21 EC0011. And today I would like to present my final year project 1, which title is Prediction of Brain Stroke Occurrence Using Supervised Machine Learning. And my supervisor is Dr. Izian Izzati binti Kamzani. So the agenda for today, we have 5 chapters. In chapter 1, we will discuss the introduction of the report. Second is the chapter 2, which is the literature review. Then the chapter 3 is the research methodology. Then in chapter 4, we do the experiment. And lastly, the chapter 5 is the results, analysis and discussion. So in chapter 1, the introduction. Stroke is a very serious medical condition identified by an abrupt interruption of blood flow to the brain. Risk factors for stroke include high blood pressure, diabetes, and smoking. Due to their reliance on static risk factors and limited predictive abilities, traditional methods of predicting stroke may not be as effective today because they frequently ignore dynamic factors and individual variation in disease progression and response to treatment. Machine learning has demonstrated the potential for identifying unknown threats, such as brain stroke. This research project focuses on using supervised machine learning methods to improve stroke prediction, precision, and efficiency. The chosen methods are support vector machine, SVM, and XGBoost. Because they are very popular machine learning methods. In the research background, strokes can be fatal or cause significant disability, and they are the leading cause of long-term disability worldwide. Symptoms of a stroke can include numbness or weakness in the face, arm, or leg, especially on one side of the body that occurs suddenly. Early recognition and treatment of stroke are critical for improving patient outcomes. This model that predicts the occurrence of brain stroke will help hopefully tackle this with accurate precision. Then a research statement. Brain stroke is a significant public health challenge with 15 million cases worldwide annually, leading to death and disability. Early detection and treatment are crucial for improving patient outcomes. Machine learning algorithms such as supervised learning hold promise in healthcare applications, including predicting medical conditions. Supervised learning models learn from labeled training data to make accurate prediction or classification on new or future data. Developing a predictive model for brain stroke using supervised machine learning could be a promising solution. By training the model on the dataset of risk factors and using it to predict stroke likelihood, we can improve stroke prevention, early intervention, patient outcomes, and reduce healthcare costs. So in this research, the aim and goal is to create a predictive model for brain strokes by comparing methods of supervised machine learning, namely SVM and XGBoost, using brain stroke datasets, and choosing the best model with high performance for brain stroke prediction research. And then the ultimate goal of the research is to develop a more efficient and accurate method of predicting stroke risk, which could allow for earlier intervention and potentially reduce the burden of stroke on individuals, families, and healthcare systems. So the following research questions are formulated in order to support the research aim. There are 3 questions in mind. First is how does the predictive model compare to other machine learning algorithms in predicting stroke occurrence and outcomes? The second question, what are the suitable techniques can be used on performing the feature selection and reducing data noise on the dataset obtained? And the third question is, which supervised learning method produces the best performance model? So in the research objectives, first of our objective is to understand supervised machine learning model for brain stroke prediction. The second objective is to validate the accuracy and effectiveness of the predictive model to testing on the dataset. And the third objective is to evaluate the performance of the developed SVM and XGBoost model with previous work in terms of accuracy, precision, recall, and F1 score. So the scope for the research is using a dataset from Kaggle to evaluate machine learning prediction. And then we The programming language used to run this algorithm in this research is Python, and the measurement of performance based on classification accuracy and algorithm efficiency. Then we move on to chapter 2, the literature review. So we will discuss only the feature selection. Feature selection is a vital step in machine learning and data analysis, where relevant and informative features are chosen from a larger data set. The objective is to identify a subset of features that have a significant impact on the target variable, improving model performance, interpretability, and computation time. Techniques like filter, wrapper, and embedded methods are commonly used for this purpose. Selecting the right methods depends on dataset characteristic and the learning task. It's crucial to pick the most suitable technique for each application to achieve better results. There are 3 types of feature selection. The first is the filter methods. These methods are used for statistical measures to rank features based on their relevance to the target variable. There are example for filter method is the Pearson correlation and the chi-square test. The second type of feature selection is the wrapper methods. These methods employ a specific machine learning algorithm to evaluate subsets of features based on their performance, such as forward selection, backward elimination, and recursive feature elimination, or RFE. And the third type of feature selection is the embedded methods. These methods automatically select or assign weights to features based on their relevance during model training, such as lasso, least objective shrinkage, and selection operator, elastic net, and the one where we use today is the extra trees classifier, which is one of the type of embedded methods. So in chapter 3 is the research methodology. To the right is the framework, the framework of this project. This study is divided into 4 phases. The first 4 components of the study framework of first phase are the literature review and determination of the problem. The second phase is a well-formed stroke dataset, which provide for the experiment during the data gathering and data pre-processing. The third phase is the development of the modeling of a supervised machine learning model for brain stroke prediction by the selected classifiers, which is SVM and XGBoost. And the fourth phase is testing and evaluation to detect the effectiveness of the classification method used in the study is evaluated and compared with the performance of other methods. So the performance measurement, which is the confusion matrix, on the left is the graph of it. The accuracy, F1 score, precision, and recall of the performance measurement for stroke prediction are used in the study. Other than that, confusion matrix will be used to accurately measure the performance of the machine learning models, particularly the XGBoost and SVM model. Here are the calculation for the accuracy, precision, recall, and F1 score. So in chapter 4, the experiment. In the proposed model, the dataset for the study was first obtained from the Calcul repository and was assigned as patient stroke dataset. The raw dataset will be handled in terms of determining whether any values are missing and normalizing the data to ensure that it produces the desired analysis process results. Then before moving on to the development phase, a new feature selection approach has been performed and put into practice. As we all know, feature selection will be one of the most crucial components in the development of machine learning. Whereas a number of characteristics in the dataset will need to be filtered and the best features will be chosen for the model. Both classifiers get the appropriate attributes as inputs during the classification phase. First is the data preparation stage. It is the most important step in carrying out the suggested supervised learning prediction for its data preparation. There are over 5,110 entries comprising of 12 attributes are present in the original dataset. Then we move to the data pre-processing stage. So in the data preprocessing stage, it refers to the steps and techniques involved in preparing raw data for analysis or machine learning tasks. It seeks to transform the data into a suitable format that algorithms and models may use efficiently and accurately. Data inconsistencies, misvalues, outliers, and other issues with data quality can negatively affect the performance of analytical or predictive models. So first we check the missing value. The dataset utilized in the study had missing values when the isNull.sum function is applied. So in the output on the left, there are 201 missing values on the BMI attribute. So after we use the scikit-learn imputer function, the missing value will be exterminated. Then we use the ordinate encoder function, which is a data preprocessing technique used to encode categorical variables that have an inherent order or ranking. It is commonly applied when dealing with categorical features that have a natural order but do not necessarily have a numerical representation. So below is the the code for the ordinate encoder. Then we move on to the feature selection stage, but before that we need to get the accuracy score before feature selection. The output will show the accuracy of the extra trees classifier on the brainstroke dataset using all the available features. This accuracy reflects the model's performance before feature selection. If we want to compare this accuracy with the accuracy after feature selection, we will need to perform the feature selection process and retrain the model using the selected features. So below is the output for the accuracy before feature selection stage. Then to get the accuracy score after feature selection, we need to do the feature selection and select the most important features. We use extra trees classifier, which is a decision tree based ensemble learning technique. It is a variant of the random forest algorithm that adds extra randomness while creating the trees. So below is the output for extra trees classifier. In the result, we get 3 features identified as important. Then we get the accuracy score after we do the feature selection. The output will show the accuracy of the extra trees classifier on the brainstroke dataset using the important features from feature selection. So before this is the below output are the comparison before and after feature selection. Then lastly, we move on to chapter 5, which is the results, analysis, and discussion. For the conclusion of this project, with regard to the prediction of brainstroke using just significant attributes, this final year project is very important. As a result, a framework is created to carry out this task. Chapter 4 discusses how 4 essential elements, discusses how 3 essential elements, which is data preparation, data preprocessing, and feature selection, played crucial roles in the study. The study's main focus was brainstroke, with the goal of suggesting a quicker and more effective method for attribute reduction. The classification phase will really benefit from this method, and patients will receive immediate treatment when we move on to final year project 2. The achievements and milestones achieved. The first objective, which is to understand probability machine learning algorithm to be classified and used for predicting brainstroke, has been achieved. The literature review on brainstroke analysis and detection techniques are completed. Recent and conventional techniques used for brainstroke prediction are highlighted and explained. The effects and causes of brainstroke are also researched. Then the phases of data preparation, data pre-processing, and feature selection, because these phases were the initial one before moving on to the crucial phase of final year project 2's classification. As a result, using extra trees classifier as feature selection, the dataset that was obtained successfully replaced the missing value and decreased attributes and picked the most important one. So in the phases 3 and 4 of the research will be conducted in final year project 2. The scikit-learn library and Python will be used to perform and fine-tune the training of the machine learning algorithms in phase 3. And in phase 4, stroke performance will be assessed using matrix, the confusion matrix, and we will measure accuracy, precision, recall, and effort score. And finally, the report discusses and analyzes the results from phase 4. That is all for me. Thank you for your time, and Assalamualaikum.